The height of a football kicked by a player can be modeled by the function h at t is equal to negative 16t squared plus 30t, where h is the height in meters and t is the time in seconds after being kicked. How long is the ball in the air? When does it reach its peak? And what is the maximum height? So first, let's try to figure out graphically what we're talking about here, right? Just as a visualization. So let's say you have a th axis instead of x and y, because the units we're using, because the variables we're using are t and h, right, instead of x and y. This represents a quadratic, and it's negative, so it's going to be opening down, right? And if you figure out what the roots of this function are, or in other words, the t-intercepts, which we can go ahead and do right now, you just set h to 0. So 0 equals negative 16t squared plus 30t. You can go ahead and just factor this to find the roots. So you can factor out a 2t, so we're common factoring, and you'll be left with negative 8t plus 15. You set each of these components of our expression to 0. So you'd say 2t equals 0, and you'd say negative 8t plus 15 equals 0. You solve for t in each case. Over here you see that t is equal to 0, and over here you see that t is equal to 15 over 8, which is equal to about 1.875 seconds. So these are both in seconds. So at 0 seconds, you're at a height of 0, or in other words, you're on the ground. And at 1.875 seconds, right here, call that 1.875, you're also on the ground. So when the ball's kicked up in the air, it goes up like this, and then comes back down, and you're back on the ground. Now the question is, 1, how long is the ball in the air? Well, it's kicked at 0 seconds, goes up in the air, comes down, hits the ground at 1.875 seconds. So I think that it would be reasonable to say the ball's in the air for 1.875 seconds. So that would be the answer to the first part of the question. Now the next part of the question is asking, when does it reach its peak? So the peak is up here, right? In other words, when does it reach that maximum height? So we have to find the time that it's at that maximum height. Now a nice little trick you can use here is you can recognize that because it's a quadratic, right, t squared, it's going to be symmetrical. And because it's symmetrical, it means that the vertex up here, right, your maximum, is going to be halfway between your two roots. So all you have to do is take the average of those two roots. So 0 plus 1.875 over 2. If you calculate that, you get about 0.94 seconds. So 0.94 seconds is the time after the kick that the ball achieves its maximum height. And now the next part says, what is the maximum height? Okay, so I know when the maximum height happens, it's at 0.94 seconds. Now I just have to find the h component of that point, right? I have to find this height. Well, to do that, all you have to do is plug 0.94 seconds into your original equation, right? You do h at 0.94. And actually that's a rounded answer, so you can plug in the more precise answer if you wish, if you've saved that on your calculator. But you plug that in, you get negative 16 times 0.94 squared plus 30 times 0.94. And if you do this calculation, what you'll get approximately is about 14.1 meters. So you can mark that up here, 14.1. So that is the maximum height achieved by this kick. Alright, let's go to the next one. A rocket is launched from a platform and its height can be modeled by the function h at x equals negative 5x squared plus 20x plus 60, where x is the time in seconds after the launch and h is the height in meters. What is the height at the time of the launch? How many seconds after launch will it return to the ground? What is its peak? When does it reach it? Okay. So the first question we have here is, what is the height at the time of its launch? So typically when something goes up in the air and comes back down, the function is representing the height from where it started, right? Like in the last example, we kicked a ball, and so at 0, the height was 0 because it started on the ground. With this question though, it specifies that the rocket is launched from a platform, suggesting that it's not on the ground, but it's higher up, right? And it also suggests that this function models its height off the ground. And so what we have to do is figure out, okay, where is the starting height? right? So we have to figure out what the height is at time 0. So we'll do h at 0. So we're finding the height at time 0. That's what that means. So let's plug in 0. So I'm just plugging in 0 for x. And what you notice is that these two terms will go away, and you'll be left with 60. So what we can say is that at the time of launch, the height is 60 meters. That would be your answer. So that means that the platform is 60 meters off the ground, or 60 meters above where the function is measuring its height from. Okay, that's the first question. Second question, how many seconds after launch will it return to the ground? So for this question, we have to figure out at what time it reaches the ground. Okay, not the platform, because it takes off from the platform and it presumably lands somewhere else on the ground. So we have to figure out, okay, when does it hit the ground again? So I'm just going to set the height to 0, and we're going to figure out at what time the height is equal to 0. So 0 equals negative 5x squared plus 20x plus 60. So let's try to solve for x. Okay, one way we can do this is by factoring, right? We can factor out negative 5, for example. You'll be left with x squared minus 4x minus 12. And then we can try to factor this, right? Simple trinomial. What two numbers multiply to negative 12 and add to negative 4? I think negative 6 and positive 2. So we'll have x minus 6 and x plus 2. And from there you could say, all right, let's solve for x. So x minus 6 is equal to 0, and x plus 2 is equal to 0. Solve for x in each case. X equals 6, and x equals negative 2. Again, the reason we're setting it up like this is because if this bracket equals 0, it all becomes 0. If this bracket becomes 0, it all becomes 0, right? Because we're multiplying. When you multiply by 0, it all turns into 0. So there's two solutions here that we have, right? So either the time is 6 seconds or negative 2 seconds. Well, you can't have negative 2 seconds, right? And the reason you're getting a negative answer for one of your times is because if you were to graph this function, it would look something like this, where you have negative 2 and 6, because when you start at time 0, you're already at a height of 60 meters. Remember that, you didn't start on the ground, you start at 60 meters, then you go up, then you come down and you hit the ground, like that. So that's the reason you get a negative time. So this is just hypothetical, right? It doesn't really exist. So that would not be the answer. 6 seconds is the answer you want. That's the time it returns to the ground, or lands on the ground, I should say. So 6 seconds there would be your answer. Now you can't always factor this nicely the way we did here to find the roots. Sometimes you have to use the quadratic formula, or you could, if you wanted, complete the square and then solve for x. So check out the video on completing the square and also using the quadratic formula. You have those options available to you as well. Okay, and then the last part of the question asked, what is its peak and when does it happen? Okay, so we can figure out based on those roots that we found, right? We had a root at negative 2, we had a root at 6, right? So that makes a graph that looks something like this, roughly, right? And so it's going to reach its peak right there. So this is what your function looks like, and you can label this x and h, right, for your time and for your height. And so to figure out where this maximum height is happening, we can say, all right, well, it's symmetrical, right? So it's going to be halfway between negative 2 and 6. So you could just average those two out. Negative 2 plus 6 over 2. That's going to be 4 over 2, which is 2. So the middle here is 2 seconds, right? Because you go 4 to the right, you get to 6. You go 4 to the left, you get to negative 2. So that's right in the middle. So you reach the height at 2 seconds. That's the second part of that last question. To figure out what the peak is, what the maximum height is, you can just plug that 2 seconds into your equation, right? So the equation h at x is equal to negative 5x squared plus 20x plus 60. We just plug in 2. So find the height at 2 seconds. So negative 5, 2 squared plus 20 times 2 plus 60. Calculate that. 2 squared is 4 times negative 5 is negative 20. Plus 20 times 2 is 40. Plus 60. 60 plus 40 is 100. Minus 20 is 80. So it looks like our maximum height is going to be at 80 meters. So at 2 seconds, you reach your maximum height of 80 meters. And that would be your final answer.